Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for October-November 2020, and the code is 9709/51. So let's move on to question number 1. For question number 1, two ordinary fair dice, one red and the other blue, are thrown. Event A is the score on the red die is divisible by 3, and the event B is the sum of the two scores is at least 9. So A, find P of probability of A intersect B. Okay, so from here, I know that since there are two dice, I will just draw a table to show the working. So it's mentioned that it is a fair dice. Both are fair dice. Therefore, it will have 6 faces. So I will label 1 until 6. Let's say this is for red dice. Okay, and another 6 faces or 6 outcomes for blue dice. Okay, so from here, to get the A intersects B probability, I will just label A and B in the table. So the A means the score on red die is divisible by 3. Okay, so when it is divisible by 3, that means the number must be either 3 or 6. Okay, so here I will label as A. All this will be the A. Okay, now for the events B, it is the sum of two scores is minimum 9. Okay, so minimum 9, I would say that 6 plus 3 is 9. It could be 6 plus 4 is 10, which is at least 9. 5 plus 4 is 9. Then 5 plus 5, I get 10. Then this is 11. So 5 plus 4 is 9. Okay, so for the 6, it will be 6 plus 3, 6 plus 4, 6 plus 5, and 6 plus 6. All this will be at least 9. Okay, so now, when we come back to the question, probability of PA intersects B, this is basically PA intersects B equals to NA intersects B over NS. Okay, so NA intersect B means that how many outcomes for the A and B. So from here, when I look at the table, I will have all these outcomes which have A and B. So obviously there are 5. Therefore this is 5 over, and S is basically 36 because 6 from the red die and blue from the 6 from the blue dice. So it means that this is 6 times 6. So at last I'm getting 5 over 36. So that's the solution for A. Now B, hence determine whether or not the events A and B are independent. So for independence, I will use this concept. Okay, so PA intersects B equals to PA times PB. That is for independence events. So another option is you can just find PA slash B equals to PB. So I will be using this formula. Okay, so means that just now we have found the PA intersects B, which is 5 over 36. So now I just need to find out what are my probabilities of PA and also PB. So PA is basically NA over NS. So now you can just count how many A in your table. Obviously there are 12. So here I will get 12 over 36, which is 1 over 3. Okay, then PB. Now for the B, you just calculate the red color, the orange color. So obviously 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 Bs. Therefore, NB is 10 over 10. Then the NS is still 36. So I will be getting 5 over 18. So now I need to multiply both probabilities. PA times PB, it will be 1 over 3 times 5 over 18. And this is going to be 5 over 54. Okay, and now you compare with the intersection probability that we have found in previous part. So obviously it is 5 over 36. So from here, I will just write not equals to PA intersects B. So when they are not equal, that means A and B are not independent. Okay, so done for this question. Now question number 2, the probability that a student at a large music college plays in the band is 0.6. For a student who plays in the band, the probability that she also sings in the choir is 0.3. Now for a student who does not play in the band, the probability that she sings in the choir is X. Now the probability that a randomly chosen student from the college does not sing in the choir is 0.58. Now find the value of X. So to solve this question, I will draw the tree diagram first. Alright, so my first branch is band, whether the student plays in the band or not. So B for band, or I just write band, and this is not band. Okay, plays in the band is 0.6. That means does not play is 0.4. So the total probabilities is 1. Then now, for those who plays in the band, the probability that she sings is 0.3. So it means that now, right, I will just write here, sing. This is 0.3. And then here, not sing, or does not sing. Okay, for a student who does not play in the band, the probability that she sings in the choir is X. So does not play and sing is X. Alright, so does not sing for not play in the band, it will be 1 minus X. Alright, so therefore the probability is 1. Then now the probability that a randomly chosen student from the college does not sing is 0.58. Okay, so this part 0.58 we cannot label from the cannot label in the tree diagram, but I know that for those who plays in the band and does not sing, it will be 0.7, so that the total probabilities here, okay, will be 1. Right, so now it's mentioned that student does not sing is 0.58, and now from here you need to find out what is your X. So I will just write here, probability does not sing is 0.8. So does not sing, it could be either plays in the band or does not play in the band. So I would say that 0.58 equals to, if plays in the band and does not sing, the probability is 0.6 times 0.7. You just multiply these two, okay, these two, and then or is plus, does not play in the band, but the person also does not sing. So does not sing is 1 minus X according to the tree diagram. Okay, so from here you just calculate left side 0.58, 0.6 times 0.7, that is 0.42. Then for the next bracket, just do expansion. That will be 0.4 minus 0.4x. Then from here, right, now basically I can just move my negative 0.4x to the left side, and this 0.58 move to the other side. So then from here I will be getting 0.4x equals to, now 0.42 plus 0.4, that is 0.82. So you minus 0.58, that is going to be 0.24. Okay, and now from here my x is 0.24 over 0.4. That is going to be 0.6. So that's the solution of this question. Now, 2 students from the college are chosen randomly. B, find the probability that both students play in the band and both sing in the choir. Okay, so it means that first student play in the band and sing. Alright, and since there are two students here, means you times the second student also with the same probability. So now band and sing means that it will be 0.6 times 0.3. Okay, so you multiply itself. So basically it is square of this probability. Then that is 0.0324. So here we use times. We use times here is because of you are considering both students, student 1 and student 2. This times means n. Okay, so done for this question. Now, question number 3. Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than 30 meters. The probability that Kayla will achieve a success on any throw is 0.25. Now A, find the probability that Kayla takes more than 6 throws to achieve a success. So basically this is geometric distribution. Okay, so I will write X is geometric distribution with the probability of 0.25 because you need to get a success. Therefore, now for your information, if let's say, okay, so X is geometric distribution with P, probability of X less equals to R, that is 1 minus QR, whereby the Q is 1 minus P. This is our formula. So now it's mentioned that she takes more than 6 throws. So here Px greater than 6. So your x is the number of throws. So to use this formula, I have to change to less equals to. That means it will be, okay, now here 1, 5, 6, 7, and so on. Alright. So more than 6 means that it will be 7, 8, and so on. So I will use total probabilities minus the previous probabilities. That means this is basically 1 minus P x less equals to 6. Okay, and now use the formula here. Use this formula. So now your R is 6. Okay, so I will get 1 minus my Q. Okay, so from here I will write P equals to 0.25. Then my Q is 1 minus 0.25. That is 0.75. Then here is going to be 0.75 degrees 6. Then now, when you open the brackets, it's basically 1 minus 1 plus 0.75 degrees 6. So I will just calculate the 0.75 degrees 6, and then you will be getting the answer in either fraction or decimal. So if fraction, it will be 729 over 4096. But if it is in decimal, then you get 0.178. So that's the solution of this question. Now B, find the probability that for a randomly sample of 10 throws, Kayla achieves at least 3 successes. So now this becomes binomial distribution. Okay, so your X is still number of throws, but then 10 throws, so your N is 10, and then the probability of success is 0.25. Okay, so here's 0.25. And then now you need to get at least 3 successes. Px at least 3. So for your information, if let's say it is binomial distributed with NP, so Px equals to x, it will be NCx Px Q n minus x, whereby the x start from 0 until n. So the x is the number of successes. So which means from here, I know that again my P is 0.25. Then my Q is 0.75. So here I will write this is basically, now you see, it is the x values, right? The x values will be 0, 1, 2, 3, 4 until 10 because your n is 10 now. You need to calculate x at least 3, means that you have to calculate 3 onwards. So it's a lot. Therefore, I will just use total probabilities 1 minus the previous. Okay, so from here, I will not direct calculate, but I will just use 1 minus px equals to 0 until 2. Alright, then from here, just use the formula. So when x equals to 0 means that no success. No success means all failures. So it will be 0.75 degree 10 failures. So px equals to 1 means nc1, then 0.25, 1 success, and then it will be 9 failures, plus 10c2, 0.25 squared, then after that 0.75 degree 8. Okay, so that will be the solution, or that will be the working. And then now when you calculate the total of the brackets, it will be 1 minus 0.525593. So 0.525593 is a total of the brackets. Then that will be 0.474, correct to 3 significant figures. So for question number 4, the random variable x takes each of the values 1, 2, 3, 4 with probability 1 over 4. Two independent values of x are chosen. If the two values are the same, the variable y takes the value. Otherwise, the value of y is larger value of x minus smaller value of x. Alright, A, draw up the probability distribution table for y. Okay, so now y has to compare both x. Alright, so now here I will just draw a table. So each of the x will take 1 to 4. Now it's mentioned that if both x are the same, then the y will be the value. So that means I will be getting here 1, 1 is 1, 2, 2 is 2, 3, 3 is 3, and 4, 4 is 4. And then if different values, then the y will be larger x minus smaller x. So when larger x minus smaller x means that 2 and 1, I will get 2 minus 1, which is 1. Then 3 minus 1 is 2, 3. 2 minus 1 again, 1. 3 minus 2 is 1. Then 4 minus 2 is 2. So you just minus, get the differences now. So here 2, 1, 1, and then 3, 2, 1. Okay, so all these are the y values, the orange color. So then from here, I will just get my probability distribution table. So here I will write probability distribution table for y. Okay, so from here, my y will be 1 until 4. So y, and followed by the probabilities. So my y values will be 1 to 4. Now you just count how many 1. So here 1, 2, 3, 4, 5, 6, 7. So it will be 7 out of 16 because you have 4 rows and 4 columns. Now when it is 2, okay, so 1, 2, 3, 4, 5. Okay, so it will be 5 over 16. Then when it is 3, so I will get 1, 2, 3. So 3 over 16. So obviously only 1, 4. So 1 over 16. So to make sure that this table is correct, make sure the total probabilities in the table is 1. Okay, so that's all for this question. Now B, find the probability that y equals to 2 given that y is even. So now here I will write P y equals to 2 given that y is even. So for your information, whenever you see given that means this is a conditional probability. So the formula for conditional probability is PA intersects P slash B, that is a condition. So PA intersects B over PB. This is the conditional probability formula. Then now just apply it. It will be P y equals to 2 intersects with y is even over P y is even. Okay, so when 2 and even, let's check. So 2 and even is basically 2. Okay, that is the intersection. Then over P y is even. Y is even means it can be y equals to 2 or y equals to 4. Right? So now when Py equals to 2, let's check here. That is 5 over 16. So here I will just write this is 5 over 16 over 5 over 16. All is plus. Py equals to 4. Y equals to 4 is 1 over 16. So from here I'll get 5 over 16 divided by 6 over 16. Therefore, the 16 can be cancelled off. So at last, I'm getting 5 over 6. So that's the solution for part B. For question number 5, the time in hours that Darwin plays on his game machine each day is normally distributed with mean 3.5 and standard deviation 0.9. Okay, this is the time spent on games machine. Now A, find the probability on a randomly chosen day Darwin plays on his games machine for more than 4.2 hours. So this is X, is normally distributed. The mean is 3.5. Standard deviation is 0.9. We always write variance. So the general form of normal distribution is mu sigma squared. And then we need to standardize it by using x minus mu over sigma. This is the formula. So then from here, you need to find probability of more than 4.2 hours. So P x greater than 4.2. So then standardize using the formula that is Z more than 4.2 minus 3.5 over 0.9. Okay, because over standard deviation. So here is going to be P Z more than 0.778. Now once you get this step, right, just sketch a graph. Middle value is 0. Then here is 0.778. And the region is greater than this line. So therefore it is on the right side. So to get this probability is basically 1 minus the previous region. Because the table in your formula list is always referring to the left side region. So here you will be getting 1 minus 0.7818, and then the answer is 0.2182, and now you round up, it will be 0.218. So that is the probability correct to 3 significant figures. Now B, on 90% of days, Darwin plays on his games machine for more than t hours. Find the value of t. So because of more than t hours means that p x greater than t. Now change this 90% to decimal. That is 0.9. Okay, and now since your x is normally distributed, so now I standardize it. It will be t minus the mean is 3.5. So you minus 3.5 over 0.9. Then that is 0.9. Okay, so now right after this, just sketch a graph. So to show this line, okay, if you are not sure where is this, so just for information, if p z more than 0, that is 0.5 because that is half of the graph. But now here is more than, okay, and this line, the probability is 0.9. Obviously, the line is on the left side because when more than 0 is only 0.5. So you have to label your line on the left hand side of the 0 so that it will have wider region. Okay, then this is 0.9. And now I will label this line as t minus 3.5 over 0.9. But now, if you refer to this graph, obviously the line is on the left hand side of 0, which means it is negative. So whenever it is negative, you must reflect to be positive because our z value in the table always positive. Therefore, when I reflect the green region, right, that becomes the blue region. So here I will label as 0.9, and the line will be negative of t minus 3.5 over 0.9 because initially it was negative. So now when you flip, it becomes a positive. So how to get positive from negative? You are multiplying a negative value. Okay, so that means from here I will get bz less than negative of t minus 3.5 over 0.9, that is 0.9. Okay, then from here I will just read the table because it is already on the right side. So from table, bz less than 1.282 equals to 0.9. Then now you just compare. Okay, so when you compare, obviously this whole value is 1.282. So I will continue on next page. So that means negative of t minus 3.5 over 0.9 is 1.282. Okay, now to get the t, I will group this minus and 0.9 together and then move it to the right side. So that means I will be getting t minus 3.5 is negative 0.9 times 1.282. Therefore, my t, just to move this negative to the right side, it becomes a positive value. So then from here, you will get negative 0.9 times 1.282 plus 3.5. That is going to be 2.3462. And now I round up to 3 significant figures. Look at the 6 and round up. Therefore, that is 2.35. So this is your t value. Okay, now see, calculate an estimate for number of days in a year which consists of 365 days on which Darwin plays on his games machine for between 2.8 and 4.2 hours. So before you find the days, we need to find what is the probability first. So then probability that x between 2.8 and 4.2. So now again standardize it. So you get 2.8 minus 3.5 over 0.9, and then becomes z because I have standardized it. And then from here, you will be getting first value as negative 0.778, and then the next value is 0.778. Then now I sketch a graph. Okay, both are same values but 1 plus 1 minus. So the region is in between. So which means I can just flip this negative region to the positive side. Okay, and I will say that it's double of this green region. So therefore, this is double of green region. So to get the green region, right, since the table shows you the region towards the left side, I will say that is the region of z less than 0.778 minus pz less than 0. Okay, that will be my bounded region or the green region. So from here, the probability for the first value is 0.7818. Pz less than 0 obviously is 0.5 because it's half of the region. That means you will be getting 0.5636. Okay, that is the probability. Now, we need to find how many days out of 365 days. So it will be number of days equals to probability times 365. Therefore, this is going to be 205.714. So I will say that it's approximate to 206 days. Okay, so for question number 6, the times t minutes taken by 150 students to complete a particular challenge are summarized in the following cumulative frequency table. So draw a cumulative frequency graph to illustrate the data. Okay, so when here less equals to, this is the time taken. So you are given the first class as t less equals to 20. Alright, so for information, the cumulative frequency curve always start with 0 cumulative frequency. That means I will start with t equals to 0, okay, or less equals to 0. The cumulative frequency is 0. So now by looking at 0 until 100, this t is on my horizontal axis. So here, let me check. Okay, I will use 20. I mean 10 for 10 for 5 squares. So this is 20, 40, 60, 80, 100. And then that is time, so t minutes. Here is 0. So now for your cumulative frequency, it is from 0 until 150. So probably 20, let me check, 20, 40, 60, 80, 100, 120, 140, 160. Okay, here. This will be the cumulative frequency. So draw the vertical axis using ruler. Okay, so now start marking the points. So when t0, your cumulative frequency is 0. So here. And then when t is 20, cumulative frequency is 12. Okay, so now from here, I have 10 squares, right? 10 squares, and the value is 20. That means 20 over 10, each square is 2 units. So now 20, 12. 12 is at 6 squared, right? Square number 6. Then 30, 48. So 30 in the middle for 38. Wait, 48. Okay, 48 is here. Then after that, 40, 106. So 40, 106. Then after that, 60, 134. So 60, 134. Lastly, 100, 150. Okay, so now join all the points here to get a smooth curve. Okay, so this is the graph. So done for this part. Now B, 24% of students takes K minutes or longer to complete the challenge. Use your graph to estimate the value of K. So because of longer, that means this 24 is not the bottom 24, it's the top 24, right? So I will just write 1 minus 24 over 100, because percentage you change to decimal, it must be over 100. Then you times total just now 150. So therefore this is going to be 114. That means now I have to look for cumulative frequency of 114, and then what is the T, okay, because the K is the minutes. So 114. So here is 110. 114 means here is 114. Okay, so please draw using ruler. Make sure it is a straight line. Okay, so based on my graph, I got 43. Okay, so it all depends on your sketching, right? So here is 43. Okay, now see, calculate estimates of mean and standard deviation of the time taken to complete the challenge. So from here, my mean, okay, to get the mean, I need to find the frequency. Alright, so now since you are given the cumulative frequency, means that I will copy this whole table. Okay, and then I need to find the midpoints as well. Alright, so I will copy the table, time. Probably I will just write T. The cumulative frequency is capital F. Now I need to find small letter f, which is a frequency, and then the midpoint is m. So here is less equals to 12, right? So less equals to 12 means it's from 0 to 12. Okay, or probably I express in this form. So the t is from 0 to 12. And then from 12 to 30, sorry, not 12, it's 20, okay? 20, 30, 40, 60, 100, 20. After that, greater than 30, less equals to 40, then 60. After 60, that is 100. Okay, so your capital F, just copy 1248, 106. Just copy the whole table. So I will get 1248, 106, then 134 and 150. So now for the for the lowercase letter f, this is a frequency. What to do is the first one you just rewrite 12, then the next one you keep minusing, right? Minus, that will be the f, the frequency. So you just minus. Then I will be getting 36, 58, 28, and 16. So for the midpoints, you get the average of these two numbers, right? So it means that it's between 0 and 20. So I plus together and then divide by 2. That is my midpoint. So therefore, I'm getting 10. Okay, and use the same method to calculate the midpoint, all the midpoints. So now my mean is summation fm over summation f. Alright, so this mean is basically x bar. that is going to be just times. So now what you need to do is you times f and m, then you plus the product. Therefore, from here, you will be getting 12 times 10 plus 36 times 25 plus 58 times 35 plus 28 times 50 plus 16 times 80, then over total F. Total F, we know that is 150. Then from here, you will be getting the numerator as 5730, then denominator 150. So from here, it will be 38.2. That is the mean. Okay, now next part is standard deviation. So now for the standard deviation, firstly, I need to calculate what is your sigma fm squared. So now fm squared means that you square the m. So all these values inside the bracket, I go to square it. The rest copy. So here is going to be 267150. That is my total fm squared. Now standard deviation. Which is S equals to summation or square root of summation fm squared over summation f minus mean squared that we have just found. So now just replace all the values. The mean 38.2. That is the actual value. Then from here, you will be getting 17.9. So that's the solution of this question. Right, next question, number 7. A. Find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that all 3 E's are together. Okay, so from this shopkeeper, you have 10 letters. Out of 10 letters, I have 3 E's, and then I have 2 P's. Okay, 2 P's, and then 5 others. So from here, since 3 E's are together, so what I need to do is I group these 3 E's as 1. That means out of 10, you minus 3, you still have 7. Still have 7 letters. But out of this 7, I still have 2 P's. Okay, and 5 others. Means that now, I need to arrange this 7 together with this. Okay, so 1 plus 7 becomes 8. So the number of arrangements, because the question does not mention that it must be starting with the 3 E's, means that you have to arrange the 3 E's as well after you group them as 1. So basically there are 8 letters now because the 7 plus the 3 E's as 1. So out of 8 letters, if you just write 8 factorial, that is the arrangements of 8 different items or 8 different letters. But now I know that from the 7 I still have 2p, therefore divide by 2 factorial. That is going to be 20160. So done for the A. Now B, find the number of different ways in which 10 letters of the word shopkeeper can be arranged so that P's are not next to each other. So if not next to each other means that I will arrange the rest of the letters first. So as H-O, the P skip. After that K-E-E, P, we ignore it, then E-R. Okay, so here we have 8 factorials. Right, so you can just write 8 factorial. Then, but out of 8, I have 3 E's. So I have to divide by 3 E's because the E's are repeating. Okay, now where is the P? Right, I have 2 P's there. So which means now your P can be in any of all these slots. So when you calculate the arrows, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 arrows, but I need 2 P's. And these 2 P's are identical P's. Therefore, I will just write followed by choosing any 2 slots for the P. So therefore, 9, choose 2. So we use C here because the P's are identical. Therefore, you are getting 2, 4, 1, 9, 2, 0. That is the first method to solve this question. I have another method which is you use when the p's are not next to each other means you use number of arrangements equals to number of arrangements without restriction minus the p's are together. That means the p's will not be next to each other when 2 p's are together. Okay, so without restriction is basically you are arranging 10 letters, but out of 10 letters you have 3 E's and 2 P's. Okay, minus the 2 P's are together. So for the 2 P's are together, what I need to do is I group the 2 P as 1. Then here you have 8. So this 8 plus this 1 becomes 9. Don't forget, here you still have 3 E's. So it means that I have to arrange all 9 letters, but then out of 9 letters I have 3 E's. So divide by 3 factorial. So that means you will be getting 302400 minus 60480. And then the answer is going to be 241920. So it's the same final answer. Here we have 2 options to solve the question. Okay, now see, find the probability that a randomly chosen arrangement of the 10 letters of the word has an E at the beginning and an E at the end. So it means that now E, and then here you have one more E. But you don't forget, we have 8 letters here, so we still have 2 P's. Okay, and then the rest will be non-repetition. So now what to do is probability is the number of outcomes or a number of arrangements that satisfy this condition over number of arrangements without any restriction. So to satisfy this condition, that means I'm arranging 8 letters, but out of 8 letters 2 are P's, so divide by 2 factorial. This is the number of arrangements whereby starting with E and ends with E, then over total arrangements without restriction, that is 10 factorial over 3 factorial times 2 factorial. The 3 is because of the 3 E's. 2 factorial is because of the 2 P's. Then from here, you will be getting 20160 over 302400. And final answer, 1 over 15. So that's the solution of this question. Okay, now 4 letters are selected from the 10 letters of the word shopkeeper. D. Find the number of different selections if 4 letters include exactly 1 P. Okay, so now here, shopkeeper. You have 10 letters, whereby 3 is, 2 P, and 5 others. Now, from here, you choose 5. So from this 5, exactly 1 P. Okay, so when exactly 1 P, now you have to consider how many E's involved. So probably I will say 1 P, 3 E's. Okay, or 1 P, 2 E, and 1 others. Or 1 P, 1 E, and 2 others. Or probably 1 P, 0 E, So it means that you only have chosen one letter. I have 3 others. Okay, so the number of selection, it will be, okay, for first case, only one way. Okay, because the E and P, the three E's are identical E's, so we do not use 3C3, and then for the 2P's, we use 2C1. No, okay, because when you use 2C1, that is for 2 different letters, you choose one. But now both P are identical P, so there's only one way. Now, for your information, this all is plus, right? So plus. Now, one way to choose 1P and 2 E's, so I need to choose one from 5 others. So all this from 5 others, right? So it means that choose one from 5, that is 5C1. Okay, or all is plus. Now, 1P and 1E, just one way. So one way for 1P and one way for 1E. So you can just ignore the 1. Then now I need 2 others from 5. So therefore 5C2. Or I need 3 others, so 5C3. Okay, then from here, you will get 1 plus 5 plus 10 plus 10. Therefore, the answer is 26. So there are 26 ways to select 4 letters, which include just 1P. Okay, so I have come to the end of the video. Thanks for watching. Please like and subscribe to the channel if you enjoy watching my video, and share this channel with your friends. So, and also stay tuned for more upcoming videos. Thank you. Bye.